Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another really fascinating guest today, involved in creating a better tomorrow on some really unique fronts. Today, we have the honor of being joined by Dr. Aysha Akhtar, who is co-founder and chief executive officer of the Center for Contemporary Sciences, an organization that's focused on catalyzing the replacement of unreliable animal testing with more effective human-specific research techniques, and is a double board-certified neurologist and preventive medicine and public health specialist. Dr. Akhtar is on a mission to ultimately educate the world, demonstrate how there's mutual benefit to both humans and animals when animals are protected properly. Dr. Akhtar is also a United States veteran, previously served as the Deputy Director of the United States Army Traumatic Brain Injury Program, helping to develop the Army's brain injury prevention and treatment strategies for soldiers. Also as a commander in the United States Public Health Service Commission Corps. She frequently deployed to assist with national public health emergencies. For a decade prior to that, Dr. Akhtar was a medical officer for the FDA, most recently in their Office of Counterterrorism and Emerging Threats, implementing studies on vaccine effectiveness and safety, and using her top secret security clearance to ultimately develop national preparedness strategies for various public health threats. She has extensively published in peer-reviewed journals, including the Lancet, Journal of Public Health Policy, reviews in Neurosciences, to name a few. She's also a fellow of the Oxford Center on Animal Ethics. Additionally, she's the author of two books, one, Our Symphony with Animals on Health, Empathy, and Our Shared Destinies, and Animals and Public Health, but ultimately argues for the need for health institutes to include animals as part of the public and public health. Dr. Akhtar is a graduate of the Eastern Virginia Medical School. She subsequently completed her general medicine internship at Washington Hospital Center and her neurology and preventive medicine residencies at University of North Carolina Medical School in Chapel Hill. She did a master's in public health at the University of North Carolina School of Public Health with a focus on bioethics. She also had a lot of cool fun facts associated with her. I'll just read a couple of them here. She supposedly makes really great cocktails. I haven't tried any. She liked classic rock, and she spent a whole year conversing with a serial killer once. So a lot of really cool themes to get into today. Dr. Aysha Akhtar, thank you so much for taking the time to come on the show.
Thanks, Ira. It's a great pleasure to be here.
It's great having you. I'd love to start off, before we get into all the serious topics we're going to be discussing. I would love to hear your background story a little more, a little bit of just everything about, where you grew up. I read about, you refusing to dissect the frogs and the fetal pigs in school. I read about you almost suing your college biology department for having you do the same thing. Take us back to the early days. How did this amazing journey that you've been on all get started?
I would say that I started out, so my parents are from Pakistan, but I was born in England. And when I was young, 6 years old, we moved here to the United States. And so even though I used to have a, East End kind of English accent, like, hey, turn off the water, that's quickly left. And now I have a very typical American accent. But I grew up here in the United States, and I kind of always knew as a kid that I was going to go into the sciences in one way or the other. I loved biology. I loved space science. If I could have been an astrophysicist, if I was smart enough, I would have done that. But I was a real science geek. And just on a so I figured I was going to go into the science in one way, either as a scientist or as a doctor. And um, so growing up, my family, we never thought about the animals on this planet with whom we interact with. We never thought about the animals who we eat. I never knew that animals were experimented on in laboratories. I was oblivious to all this stuff. And then at some point when I was in high school, we started becoming more and more aware of the situation with animals around us. And I remember there was anyone's watched Star Trek: The Next Generation, there was one episode in which Commander Riker said, "We no longer enslave animals for the purposes of meat." And I thought that was interesting,
Mhm.
and it started to make sense to think that we're going to be in a future in which we see animals differently than the way we do right now, when we don't use them for our own purposes, where we see them as the individual beings that we are. So that led me on to a whole journey to really learn about the many ways that we use animals, including animals in experimentation. And it bothered me extremely how much animals suffer in laboratories. And so I used to then got would decline to dissect animals. And as you mentioned, I tried to almost sued my college for trying to make me experiment on animals as part of my biology degree. That didn't happen. I ended up changing my degree to English, which actually ended up being a good thing anyway, and then went into med school. But during the course of med school, I also as a physician, started seeing the intersection between
Mhm.
how we treat animals and human health, including issues of antibiotic resistance, factory farming, climate change linked with that, pandemic risks associated with factory farming, and of course, animal experimentation. And as a physician, I really started and at my time at FDA, I really started to see the problems with using other animals as so-called surrogates for human biology. And so I formed Center for Contemporary Sciences, long story short, in 2020 to help create a new way of doing things in medical science that is more effective, more reliable, kinder, and actually better also for human health.
Let's because I mentioned it in the bio of the show, your extensive publication record. I went to PubMed and I took a look at a lot of what you've been publishing in the last couple of decades. And I thought before we got to the center, I thought I'd just touch on a few of these to show the audience sort of the progression of all of this and what you saw. And I thought an interesting place to start, as you were just mentioning about the models, was this review Neurosciences 2008, where you basically outline all the problems. The paper is entitled Animal Models and Spinal Cord Injury. And here you really go into a deep dive in terms of everything from biokinetics of spinal cord injury, circulation differences between animals, the stressors that they run into, the interspecies, interstrain differences. Say a couple words about what was going, because clearly, you didn't want to do the dissection, but you're working on it. I have not done spinal cord injury models, but I've seen them. They're pretty nasty. Talk a little bit about what's happening in 2008 and why you wrote this paper at that time.
Yeah. So, as part of my training as a neurologist, I saw many patients come in to the emergency room with spinal cord injury. And spinal cord injury can be devastating, as you can imagine, because unless it's a minor injury, it can cause paralysis for long-term paralysis, right? And despite the fact that we've so-called treated spinal cord injury in animals in experiments for decades, we have no effective treatment for human spinal cord injury. And so it's really hard being a neurologist and seeing these people come in and knowing that, unfortunately, we don't have a good treatment to offer you, right? To say that to a patient, there is no good treatment. The only thing we offer sometimes is a steroid that's been around for a long time and is questionable at best. So I really wanted to look into what is some of the problems with why we don't have good treatments. And so I started to really look into the animal experiments that were done and how that could possibly contribute to the problems of that we face today of not having any effective treatment for human spinal cord injury. And as I started digging into it, I really saw, my God, there are so many differences between what they're seeing in animals in the lab and what actually occurs in humans with spinal cord injury. And it's mind-boggling how many differences there are and how that could truly lead scientists along a wrong line of investigation. And so it was on one part of the journey of me really looking into really the problems with animal experimentation.
Mm-hmm.
Maybe 200 years ago, you can look at a cat's heart and say, yes, it pumps in the same general way as a human heart. But we're not at that level anymore with medical science, right? We're now looking at the subtle nuances of genetic expression, biochemistry, molecular physiology, and so on. And little differences between species, between a rat and a human, a dog and a human, for example, can mean significant differences in the results of a study, significant differences in whether or not a drug is going to be safe and actually work in humans. So we're still, when you think about it, in medical science, we're still clinging to a process that's old.
Right.
And I don't know of any other scientific field that does that, right? I mean, you see changes. Every scientific field changes. We don't use the initial rockets that were used for the Apollo 11 rocket anymore for space flight, right? We update, we renovate, we move into better technology, but we're not really doing that with medical science by clinging on to this process of using animals as models for human disease, and they are not models for human disease, not anymore, not at the level where we are.
The next year, in 2009, in the American Journal of Preventive Medicine, you write an article, Health Professionals' Role in Animal Agriculture, Climate Change, and Human Health. And I thought this was fascinating. I mean, this could have just, you could have written this yesterday, because, I mean, what this paper is really about is, this very hot topic that we've been talking a lot about on the show, namely One Health, and sort of the convergence, the intersection of, we have to think about all these things, whether they're the consumption of our foods, whether they're, the next zoonotic problem that comes because we knock these trees down over here, and the baboon likes to bite the cow, and so forth and so on. And we spent a little time on that to say what was going on at this point, because obviously there's the promotion of plant-based diet, which is great, but you really bringing up important topics in terms of environmental degradation, in terms of zoonosis 15 years ago, which clearly ring a bell right now with everything we just went through the last couple of years.
Yeah, it's a very different topic from the 2008 paper, right? Where I was looking at spinal cord injury.
Yep.
And that's just really me, because I'm more interested in larger issues in health. And so that's why I went into public health and went to the FDA and so on. And so it was really me looking at neglected issues in the medical sciences and public health. Neglected issues that are so crucial to our health and well-being. And so when you think about it, in public health, we know that how we eat, how we work, how we house ourselves, how we share resources or don't share resources, how we relate to our environment, how we play, all affects our health, emotional, physical, and social well-being. Despite acknowledging all those interconnections, the public health and the medical science community has not acknowledged one crucial connection that has played a role in our health from the very beginning, which is our interaction with other animals. And so when you think about that, it is mind-boggling that this is really a very neglected part. So yes, we're starting to see some conversations about the risk of zoonoses, infectious diseases that can pass from one animal into a different species. Could happen from other species into humans, or the reverse. We can pass infectious diseases to animals. Or, looking at the climate change risk associated with factory farming, or the zoonotic disease risk and pandemic risk associated with the wildlife trade and habitat destruction and so on, because these all affect other animals. And so even with One Health, there's some touching on these issues, but they don't go far enough. They don't actually fundamentally address the root cause, which is we have to fundamentally change how we treat other animals. We cannot continue to do what we have been doing for the last, I would say, half a century in this regard. We have to fundamentally change. Our health and well-being demands it. So One Health approach, for example, looks at things like how do we curtail physical illnesses? And they focus on surveillance, for example, which doesn't work, because by the time you recognize what a virus could cause a pandemic, when a virus could cause a pandemic is when it has started to cause a pandemic. Or they focus on vaccines and antibiotic use, which can lead to mutation of viruses, so that they mutate out of being susceptible to viruses, and antibiotic resistance and so on. But they don't really address the fundamental issue, which is how we treat animals. So factory farms are a major cause of pandemic, or a major future cause of pandemics, explicitly because of the way we treat animals, because of the fact that animals are crowded, they're treated miserably, they're stressed, and they undergo immense distress. And so their immune systems are down. And because of the crowding, it makes it easier for them to catch a virus and pass it on to each other. And each time they pass the virus on to each other, the virus can mutate into a deadlier form. And that's what can cause a pandemic. So I wrote that paper going back because I felt that the public health community needs to start addressing the interconnectedness of these issues. Unfortunately, despite the fact that that was almost how long? I mean, 15 years ago, something like that. We haven't really changed, and that the need to address those interconnected issues are even more today than ever before. But the attention on these issues are just the same as they were in 2009, which is minimal.
And then one more place I want to start, and we'll get to the Center for Contemporary Sciences next. But I think this is important in sort of rounding out the full picture of your background. So I think the next year maybe you head to FDA, and then you're there for a period of time, and you're publishing 2011 on different issues with vaccines and safety and so forth. I was just interested because just obviously being at FDA and thinking of my own experiences in drug development and going to FDA in the past, I think maybe the lay public may think, there's some mice, and then eventually there's some humans, but there's a lot of animals in between, right? We have to do, larger animals, and there's these 3-year dog carcinogenicity stuff. There was a lot of stuff we had to do. And then also, the other thing I was thinking about, because you're involved in countermeasure type stuff as well, per the bioprotection and preparedness. I remember there was this animal rule thing proposed at FDA years ago when it came to some of these countermeasures. Talk about, I mean, obviously there you were at FDA for a decade, and you have to deal with both these topics, and clearly a lot of animals are, involved in these processes that you are helping to regulate. What was that like?
So, for anyone listening, they're like, oh my gosh, she's all over the place. But, that's one thing about my career, is that I didn't feel boxed in. I didn't let someone else's, category of what a doctor should be box me in. So I'm really looking at ways at how we can rethink how we approach health. And so really looking at the interconnectedness of all these issues that I mentioned, which also includes the use of animals in experimentation. So that comes back to the FDA. No one, I don't know of anyone who says, my lifelong goal is to go work at the FDA. I don't know anyone who says that. And I happened to work at the FDA almost by chance. And so I ended up staying there for 10 years. One of the things I learned when I was at the FDA is that the FDA, with rare exception, actually, I don't even know if there is any exception, requires any new drug or vaccine to be tested on at least 2 different species before the FDA will allow it to move into human clinical trials. Now, most people think that's a good thing, right? That means that a drug will only move into clinical trials if it's safe for humans. It's been tested on animals, so it must be safe. Well, that's not quite the case. That gives us a false sense of assurance. What we do know now is that despite the animal testing, or because of it, 90 to 95% of all drugs and vaccines that are found safe and effective in the animal testing end up being unsafe and or ineffective in humans. Now, you think about that 95% failure rate. So if I were to hop on a plane and the pilot said, all right, strap down because we have less than a 5% chance of landing safely at our destination, you can imagine I will hop off as quickly as possible, and everyone else would do the same with me, and we would demand an overhaul of the entire airline industry. We would never accept such a dismal failure rate in the airline industry, but for some reason that continues here when it comes to the very safety of our drugs and the effectiveness of our drugs and vaccines that we put into our own bodies. And that's because the FDA is a bureaucratic organization like every other governmental run organization. They are incredibly slow to change, despite the incredible failure rate in animal testing. So the FDA is a bit schizophrenic in some ways. Some pockets of the FDA acknowledge this problem with animal testing, and they want to start looking into how do we have more effective testing methods that are really more reflective of human biology. So these are human biology-based models, right? That could be more effective, more reliable, more predictive than animal testing. But then you have other pockets of the FDA that create things like the animal rule that you mentioned. Now, the animal rule was created because in bioterrorism, or if we're talking about emerging threats, which could be pandemics like what we experience, we stockpile drugs and vaccines in preparation in case any of these things happen. If a bioterrorist weapon goes out there, smallpox is released into the environment, for example, anthrax, for example, and so on. And for a lot of these vaccines and drugs, we hope they're going to work. We hope they're going to be safe in people, but we really don't know until we actually try them out. And so when you think about it, that typical process of seeing if, of moving a drug from animal testing into human clinical trials can't really happen with a lot of these diseases that we think about when we think of bioterrorist attacks. You can't, there are some ways, but you can't expose people to anthrax to see if a vaccine would work, right?
Right.
So the animal rule was created to say that for these kinds of drugs and vaccines that could be used for emerging threats like bioterrorist threats, we can stockpile medicines and have them ready to go based on efficacy testing in animals only. You don't need to go into human clinical testing. So it circumvents that typical process. Well, there's good and bad to this. Of course, we cannot do this kind of testing ethically in humans. You can't expose them to anthrax and test a vaccine. You can do certain types of tests with people. You can test a vaccine in people for safety, right? Sure. You can test a vaccine in people to see if certain markers come up that indicate that the vaccine will fight against a certain type of virus, for example. You can see if the immune system gets stimulated, which what is a vaccine is supposed to do in human populations. So you can do things, you can do human testing without exposing humans to the actual disease. So you can still do many other types of forms of clinical trials to see if the vaccine, to get an indication if a vaccine, for example, will be effective. The other thing with the animal rule is that we know that animal testing does not predict whether or not a drug or vaccine is going to be safe and effective in humans. My God, there's a 95% failure rate. So while some pockets of FDA recognize it, pockets come up with something that just seems to make no sense, like the animal rule, which is perpetuating the use of animals, even though we know that it's not animals don't predict human outcomes. So that really doesn't make sense. And one of the things that one of the roles I had when I was in the Office of Counterterrorism and Emerging Threats was to help set up these surveillance systems. So knowing, even though, there's this animal rule, a lot of people kind of internally recognize that we really don't know if these drugs and vaccines are going to work and be safe in humans until we actually try them in humans. So my role was to help create a surveillance system to allow us to see if these drugs and vaccines will work and will be safe in people once they are tried in people, in the population, in the face of an emergency.
Excellent. Excellent.
Yeah.
Okay.
And
so
you might want, so what do we do instead of animal testing?
No, that's it's a perfect segue. Thank you. I mean, into the Center for Contemporary Sciences. As I mentioned in the bio, you are looking for, as you say, these human relevant alternatives, and you're involved in both the science and technology, spurring the innovation at the same time, looking at existing policy and advocacy. Talk about this because, and just as I'll throw a little piece in there from that. So a couple of months ago, Dr. Bumpus from FDA was on the show talking about the science group and so forth. And she was very keen on organs on a chip and organoids and things like this. And I know that's a major part of some of what you're looking at. Take us through a little bit about what technologies, obviously, you talk about organ on a chip on the website, but as we go in that sort of continuum of an organ on a chip to an organoid to potentially some of this more bleeding edge stuff that we've talked about on the show, and whether it's digital twins or in silico studies, there's a lot here that can be ultimately complete replacements for animals. So take us through a little bit of what you're up to and a little bit of the strategy of the organization, not just in funding the innovation, but getting people on Capitol Hill and the Beltway on board.
Sure. So let me do that by painting where we can be in 20 years in medical science.
Cool.
And that is an era of what we call personalized or precision medicine.
Mm-hmm.
So think about human clinical trials. We have
mm-hmm.
to have diverse people in clinical trials because
mm-hmm.
what may be safe and effective in you, Ira, may not be safe and effective in me.
Right.
May not be safe and effective in my 80-something mom, right? Or safe and effective in a 12-year-old boy from Sudan, right? So we know there's so much diversity within our human population. So in 20 years, where we could be if the biomedical science community and the policy and the funding aligns is an era of personalized medicine in which, let's say I develop a colon cancer and you develop a colon cancer. Let's say we're diagnosed with the same category of colon cancer. Doesn't mean that the cancer is really the same in you and the same in me. Sure. Doesn't mean that the same drugs are going to work for you and work for me, or be safe in you or be safe in me. But in 20 years, conceivably, scientists and doctors can take my colon cancer cells and my healthy cells and use them to create an Aysha model on a chip. So can actually create a model based on my biology that encompasses cardiac tissue, lung tissue, kidney tissue, colon tissue, a vascular system, a neurological system, a lymphatic system, integrating all of these different systems and all the multiple organs on the chip that captures me, that captures my body, my biology, but on a microchip. And then doctors can screen for whether a drug is going to work against my disease and be safe for me using my model, my body on a chip model. That's where we can be in 20, 30 years. Now, to get there, we need to move into a different technological realm than where we are right now, which is archaic, which is thousands of years old. And I say that as a pseudonym or I don't know what the right word is, as a, in place of animal testing, right?
Sure.
That's the old tool, that the archaic tool. So organ on a chip basically is where you distill a major component of an organ, a functional component of an organ, onto a microchip. So using human lung cells, for example, there have been human lung on a chip created. And these human lungs actually breathe and function like a major part of a human lung. There's a human kidney on a chip, a human liver on a chip, even human mini brain on a chip. And then, as I mentioned, the next step is really to integrating these with more of a systems approach, including the neurological system, the circulatory system, and so on. So you create a integrated human body on a chip. And what's great about these is that they are based on human biology. They are human tissues. They are models of human organs and the human body, unlike the rat body or the dog body or the cat body. So you can then use these body on a chips to understand basic biological mechanisms. For example, you can use them to explore diseases and how diseases originate and progress through the body. And you can use these models to screen drugs and vaccines to see if they're going to be safe and effective. You can go further. You can see if they will be safe and effective in a certain population, because you can capture cells from different populations within the human population, and actually one day run clinical trials in the lab. So you can have models that represent, a 95-year-old woman from Pakistan, for example, and a model that represents a 12-year-old boy from Sudan, right? And one that represents my very Caucasian husband, right? So you can run clinical trials using these models before you actually have to take a drug or vaccine and try them out in living human beings. So there's so much potential here. And what is needed is much more funding and development and a real attempt to further develop and refine and improve these types of technologies like organ on a chip. There's other types of technologies like using bioprinting to actually print miniature organs called organoids in the cell. Yeah, I mean, in the lab. One day we'll be able to actually bioprint actual organs that we can use for organ transplant in addition to research. Yep. So that is the area, that's where medicine can go. So going back to the Center for Contemporary Sciences, what we do is we help get us there. So we're a nonprofit that helps create an ecosystem that supports the discovery, the development, and the improvement of human relevant testing methods that are relevant to human biology. So it would include incorporation of digital twins, AI, organ on a chip, bioprinting, traditional cell culture techniques, other types of computer modeling, as well as imaging techniques and traditional pathology results and clinical trials, and really all together can give us the best answer we need to determine how best to treat a person's disease.
And so you mentioned some of the tools that are, and when we talk to regenerative medicine people all the time, when they're talking about bioprinting their organ, they always go to the organoid as sort of this intermediary step that can be used for exactly what you're talking about. How do you, I mean, you mentioned it's a nonprofit, but what are some of it? Because I remember reading about some collaboration you're doing right now, I think with a group of investors. What are some of the sort of what's going on right now in terms of sort of the looking at if labs or startup companies or whatever come to you to partner in some way, what activities are being undertaken right now by the organization in April 2023?
Right. So a couple of things that we've done. It's in a small scale, but we're hoping to scale it up, I guess, is helping to match investors with startup companies in this space.
Mm-hmm.
And investors don't, really know about this space very well. So we also provide education to investment groups. We also provide general education to the public to really show them where medical science can go if we're willing to discard an old, broken system, which
Mm-hmm.
is animal testing. And so we do that by talking to the media and writing op-eds and publications to really help people to come onto this journey of personalized medicine. We also work on policy changes. What kind of policy changes can we create that will further spur innovation in human relevant testing methods and incentivize more and more innovation in this area? So for one policy we worked on was the FDA Modernization Act 2.0.
Mm-hmm. Mm-hmm.
And that was signed into law by Biden in the December of 2022.
Right.
Almost record time for a law. But what it does is that it goes back and changes an old 1938 mandate that required by the FDA that drug developers must do animal testing for to check for the safety and efficacy of their drugs. Now, what this new law does is that it expands the type of testing method. So it removes that absolute mandate that it must be animal testing. And it states now there are other types of methods that can be used, human relevant testing methods that can be used instead, like organ on a chip technology.
Mm-hmm. Mm-hmm.
So it's a way to, it's a stepping stone. It doesn't, change the full paradigm, but it's a step to start hopefully incentivizing drug companies to more and more start using these more human relevant testing methods that can better tell us whether a drug is going to be safe and effective in humans, and that can cut the cost of the whole drug development pipeline, because the high failure rate, you can imagine,
Sure.
is very cost prohibitive, and hopefully reduce the cost of drugs for us as well. So
Mm-hmm.
that's one policy that we worked on. And we're looking at other types of policy and regulatory changes that can be made that can provide greater support for these new technologies. So one area where there really is a need of change is in how NIH gives us grants.
Okay.
What we know is, and this was based on a 2008 statistic. Within 2008, it was reported in a publication, the National Academy of Sciences, that at about 50% of all NIH grants go to research that also include animal testing.
Mm-hmm.
We suspect the other 50% goes to human clinical trials, because human clinical trials can be very expensive. As far as we know, we haven't found any other statistic that suggests that that number has changed.
Mm-hmm.
So what that means is that 50% of NIH's grants goes towards perpetuating a broken system, animal testing. There needs to be a change here. And so we want to help create a change that means that less grants are going towards animal testing, and more grants are going towards the discovery and development of more human relevant models and tools. So we talked about organ on a chip, and that was, a technique that's come about really pretty recently over the last 10 to 15 years. And, it's considered a real big breakthrough.
Mm-hmm.
There's still more improvement to go in organ on a chip technology, but it needs more funding to be
Right.
improved and become better and to be more widely used. Also, we need more funding for discovery of other methods. Who knows what the next big breakthrough could be?
Right.
What could be the next great model for human biology? So we also support policy changes. We try to work with regulators in Congress and state governments, for example, in helping to create policies that can spur even greater innovation in this area.
Excellent. Excellent. So moving from the inappropriate application of animals to the appropriate, and focusing on your books now, and I had the opportunity, this was a couple of years ago now, to talk with Dr. Phil Tedeschi at the Human or the Institute for Human and Animal Connection at the University of Denver. I know there's some other groups that focus on the human animal bond. They were focusing, I remember, if I can remember properly, it was primarily dogs and troubled youth, not serial killers. But can you say a little bit about? Obviously, that seems like like the terminal cancer patient in the clinical study. That's the tough patient to go after. Tell us that story a little bit, but then please tell us a little bit of what you're focusing on currently in terms of the human-animal bond and some of these proper uses of animals in the healthcare systems or the public health system.
Sure. So, if I had another life, if I had multiple lives, I'd be, in addition to doing what I'm doing, I would have been an astrophysicist if I was smart enough. I would have been an artist, and I would have probably been a forensic psychologist
You
because
are
I
an
love that.
artist. What are you talking?
Yeah, but I mean like full time, right?
Okay.
But and I probably would have been a forensic psychologist because that does fascinate me, that whole field. But as a neurologist, I've definitely had a lot of experience in that field because
Mm-hmm.
so many neurological diseases can cause changes in personality and behavior, or and so there's a lot of psychiatric repercussions of a lot of the neurological diseases people can face. And so I've had my share of working with people with many different kinds of psychological ailments. So but the serial killer was for a book, with the book that you mentioned earlier, Our
Mm-hmm.
Symphony with Animals. And it was really kind of an overview of how our relationship with animals affects our well-being. It was a broad overview. So looking at the good ways that in which positive interactions and relationships with animals can boost our health and
Mm-hmm.
our well-being, and the negative things that can happen when we mistreat animals, for example, or we treat them like we do in factory farms, or we continue to use them like we do in experimentation, how that actually slows or is a block to progress in medical science, for
Mm-hmm.
example. The serial killer thing was to really, it was the beginning of a section in the book in which I really look at the connection between violence towards animals and violence towards other humans. And there is a very well evidenced connection between violence towards humans and violence
Mm-hmm.
towards towards animals. We know that now. There is no denying that. In fact, the FBI has started to recognize that and has started to treat violence towards animals with greater significance or greater seriousness than what it used to 20, 30 years ago. If not for the sake of the animals themselves, at least for the sake of the fact that violence towards animals is very much connected with um, the killing and violence towards humans. So as part of the beginning of that exploration, I started with the extreme. I said, okay, let's look at an extreme case. And here it's been really studied quite well that there is often a link between serial killings and how they get started, and how they get started to kill humans, and how that's connected with their experience with killing other animals. And so I reached out to a serial killer, well, convicted serial killer by the name of Keith Jesperson, who killed,
Mm-hmm.
gosh, it was a while back. I think it was 8 women. I think he killed 8 women in his spree before he was caught. And I really wanted to explore his past and how did he, get into this, how did the serial killings even start? And was there some connections he had with violence towards animals in the earlier part of his life? And yes, there was. He had quite a violent past towards other animals as well. So that was the beginning. And then I went into showing even how this human animal violence connection goes well beyond serial killers. They're the
Mm-hmm.
extreme example. But when we look at society as a large, if we look at violence towards animals in slaughterhouses and violence in the towns where slaughterhouses are, you can see there is a strong connection. So there's a lot of ways you can look at this, but yes, violence towards animals is very much connected with violence towards humans, and it should make sense, right? If you accept violence in one form, either as an individual or as a society, it makes you more open to accept violence in other forms as well.
Mm-hmm. And loop that into the Farm System Reform Act, if you would, because I think there's a now as we're coming now to not just the cruelty, but the zoonotic problems with factory farming. Say a couple words about because I know this is part of your advocacy and policy work about
Yeah.
the Farm System Reform Act as well as the Preventing Future Pandemics Act.
Yeah, so the Farm System Reform Act, I mean, it indirectly addresses some of the violence that happens to animals on factory farms and in the slaughterhouses by it's a bill. Senator Cory Booker is one of the co-sponsors of the bill,
Mm-hmm.
but basically it calls for a moratorium on factory farm, meaning that at a certain date, no new factory farms would be built in this country. What
Mm-hmm.
most people don't realize is that about 98% of all meat, eggs, and dairy products come from factory farms everywhere in the world.
Mm-hmm.
So when people are eating meat and eggs and dairy, they are most likely eating animals from factory farms. So this bill would put a moratorium on the factory farms and then call for, if it were to pass, would call for slow phasing out factory farms. And that's really the direction we need to go. Not only would that be better for the animals, of course, because then fewer animals would be suffering in these kinds of conditions, but there's definitely a public health, a human health need for this kind of a bill because we do know that factory farms are breeding grounds for new infectious diseases. And we
Mm-hmm.
suspect that the next pandemic will come from a factory farm. It is highly likely that the next pandemic,
Yeah.
and a far worse pandemic than what we experienced with COVID, will come from a factory farm. We also know that factory farming, the whole animal agriculture industry, in fact, is one of the most significant contributors to climate change, environmental destruction, and pollution of our air, water, and land, and users of our resources. And part of the reason for that is because most of the land used for agriculture is for feed crops that are fed to the animals, which then are converted into to meat, eggs, and dairy. But it's an incredibly inefficient process. About, for example, 10 pounds of plant protein are needed to make 1 pound of meat protein.
Mm-hmm.
So we
Right.
cannot continue the way we are. We just cannot. Our planet cannot continue to sustain our burgeoning human population, if we keep continuing this way. So some real
Mm-hmm.
changes need to be made. So this bill will not only support greater protection for animals, but also be a way to start reducing the risk, the real threats we face in the near future.
Mm-hmm. You wrote it was interesting. You wrote a fascinating article in 2016 in the Huffington Post, and it was entitled "Why Does the Death of a Gorilla Hurt Us So Much?" And you go into this theme of something called biophilia and this emotional affiliation between all animals. Maybe so when we talk about sort of the human animal bond, we don't want to think of dogs and cats and horses and so forth, but in this concept of biophilia, it's much broader, right? It's the entire ecosystem. It's fascinating because it made me think of this other project that I was involved in a couple of years ago. It was a gorilla project where there were a bunch of gorilla deaths here in the United States in various zoos. Something called what was it called? Fibrosing cardiomyopathy, and we figured out that they weren't getting certain plant foods that they were normally eating in Western Africa in the zoos and all these
Mm-hmm.
terpenoids and alkaloids and so forth, the natural environment held for them. And we made the connection, and it was a really fascinating project. But coming back to this theme of biophilia, I think it's an important one because I think this whole concept that you're trying to get out there in terms of the human animal bond, it extends. It extends beyond, we're a bird family, we have birds in the house here, but it's
Mhm.
really much more than that. Say a couple words about biophilia, if you would.
Yeah, so in its simplest term, biophilia means a love for life.
Hmm.
And what that really means is a love for life in just about any form, right? We are living beings, and so we're attracted to other living beings, whether they're insects. Yes, we're attracted to we're fascinated by insects, whether they're plant life or whether they're animal life. So you think about it, it's the reason why people go to zoos, even though I actually am so opposed to zoos because of I just don't think that they're effective at what they're claiming to do. And anyway, but I won't go down that line. But it's the reason why people go to zoos because we're fascinated by other
Right.
animals. We'd like to be around other animals. We'd like to be around other life forms, right? So, and that includes companion animals. That's why we have dogs and cats in our lives.
Hmm. Hmm.
We love them, but we also get something from them, right? We feel emotionally better
Right.
being around other animals. It's why we go on nature walks because
Hmm.
we feel better being connected with life and with nature. So that's what biophilia really means. And when you think about it, it is a natural part of who we are as a species. It's integral to who we are as a species. But going back, and again, for anyone listening, they're going to say, oh my God, this doctor's all over the place, factory farming, animal testing.
Hmm.
But when you think about it, they're all coming back to the same core thing, which
Yep.
is the interconnected of human health and well-being with the well-being of other animals and the well-being of the planet at
Yep.
large. And we have to start looking at that interconnection. We have to. We cannot continue on the way we are right now.
Yep.
So biophilia basically is that. It kind of, is a, I would say it really brings to the fore of this part of human nature, part of our species, to want to connect with other life. So if we want to connect with other life, it's important for us to thrive mentally, socially, physically. When you think about it, we depend on the plants. We for medicine, for food, for example, and so on. We depend on the on sustainable ecosystems to keep mosquitoes down, for example, and other things like that. We need a good, healthy planet and good and healthy beings on this planet.
Yep.
So
Yep.
and so in order to get there, we have to reconnect with that biophilia in a sense, which is part of who we are. I think that we've really disconnected from that in so many ways. And people have been saying this for a while, and so this isn't anything new. We live indoors now. We don't really go out in nature as much as we used to, right? We have people have their windows closed all year round. They don't
Yep.
open their windows to hear the birds outside and to get the fresh air. So we're so disconnected from nature, and we're destroying nature, and we're destroying other life forms. We're destroying other animals, and that is destroying us.
Right.
And so we need to change course. And so, when I talk about biophilia, we talk about how like the death of a gorilla hurts us so much. It really gets back to the death of a gorilla hurts us so much because we feel a connection with
Right.
that gorilla. This was about one particular gorilla.
Hmm.
We all, as a society, felt a connection with that gorilla, even if
Right.
we never met that gorilla. But we did. And that it's because of that inherent biophilia we all have as members of the species.
Hmm. And there's a small interesting flip side to the to my part of that story in that we actually learned from what the gorillas were eating in West Africa, which helped lower their C-reactive protein. Some very interesting leads for C-reactive protein lowering drugs. So, but that's a side story.
Yeah,
But
yeah, yeah.
there's a lot they learn from us, and we learn from them, and that's exactly why So I just wanted to point that one out because I enjoyed reading that one, and I'm glad you shared that. And it is all connected. I mean, you might say you're involved in all these here, but you're not. It is all one central theme, and that's why I was just so impressed and and taken by your bio. Um, Actually, we talked about. the fact you make great drinks, and well, we didn't talk about your art, but the one other thing I just have to ask about, because I'm a huge sci-fi and horror, well, I'm a sci-fi and horror movie fan, but I read that that you like to spend a lot of time reading sci-fi and horror in your
Yeah,
what's that all? What do you like to read? Do you like horror films as well?
I do. I like
Okay.
horror films,
And
not
if
the
you
torture films. I don't like anything that's involving torture. I
so
just
you
like
haven't
good old-fashioned horror.
okay, and tell us a little bit of that, because I now
Yeah.
I have to go
Oh,
further with that one.
like the gothic horror and
Okay.
just there hasn't been a lot of good horror films that have come out, quite honestly, in a long time. There have been a few, but yes, I like horror films. I like horror books. I'm always reading horror books.
Okay.
There's the whole Stephen King, and then
Sure.
there's Stephen King can be good or bad depending on how long the books are.
Oh yeah.
But obviously there's a great line of work, not just by Stephen King, but many other. I mean, I'm for some reason I'm blanking on all the names.
That's
There's
okay.
a lot of good sci-fi authors. I loved Ursula Le Guin, for example.
Sure.
And more recent authors include, oh yeah, yeah, my God, why can't I remember him? Jack something. And that's all I can remember about one of my favorite sci-fi authors. But yeah, I love sci-fi. I like a range of books. So historical fiction, sci-fi, horror, mystery, suspense. But I'm an avid reader and reader for fun.
Sure.
I have
Sure.
to read for fun.
Me too. Me too. Yeah,
Yeah,
I just
you
didn't
too.
know. We're a big horror movie family, and it just again connecting to this story for a second. There was a really horrible movie from 2018 called The Farm. And I don't know if you've seen this one, but it's basically
No.
okay, the experience of what happened to humans if they were treated as the animals in
Oh.
the factory farm, and the animals were actually running the farm. And it's a violent and gruesome, but it's anyway. Yeah, you might want to check it out offline, but I don't know if it's something you want to see because it's rough, but it comes
Yeah,
access on these themes.
it
But
sounds like it sounds like a sci-fi book. Was that based on a sci-fi book?
I'm not sure.
Okay.
I'm
Okay.
not sure, but I remember watching it. I'm like, oh, this is not that entertaining, but I see what they were going for. It was a
Huh.
rough one, but in a case of some of what we've been chatting about, it's kind of um
Yeah, interesting.
what else is coming up, Aisha? Anything else that we should know about in terms of conferences you're going to be presenting at, talks you're going to be giving, anything else for 2023 in the coming months per the Center for Contemporary Sciences or some of your other initiatives? Please
Sure.
take the floor.
Yeah, so we're going to be launching what's called the Animal-Free Precision Medicine project, which is really it's a more collaborative effort to really move medical science towards that personalized precision medicine image that I gave earlier. And of course, that's it's not going to happen with animal testing. That's going to happen by moving away from animal testing as well.
Mhm.
And part of that includes a prize that we are helping. We're doing this in partnership with another organization called the Methuselah Foundation, which is
Sure.
an organization promoting healthy human lifespan and
Hmm.
longevity. And so they're going to be launching their next innovation prize in this area in animal-free precision medicine,
Yep.
basically. And so we're going to be helping them with that. And then, so that's going to be very exciting. And then, so I would say to the audience, if they're interested about this, follow us, stay tuned. We're just building this program, and I think we're going to try to go big with this program to really just cut through, really all the crap that exists right now in the medical sciences and just get to the heart of the matter, which is let's study human biology and let's find treatments and cures for human diseases.
Excellent. Excellent. Um, Great message, great mission. Really wishing you the best with it as you continue to develop the programs. For everybody that's going to be listening to this particular episode of the show across the various podcast networks or watching on the YouTube channel, again, you've been listening to Dr. Aysha Akhtar, co-founder, chief executive officer of the Center of Contemporary Sciences. Aysha, I want to thank you again for taking the time out of your schedule to come talk to us for a little while about what you're up to. Obviously, thank you for doing what you do. And as we like to say on our show, thanks for helping to create a better tomorrow through these initiatives. Really, really fascinating stuff. And I look forward to continue to follow you.
Thank you so much, Ira.